Hi everyone, my name is Daniel Zakrisson and I'm the CEO and co-founder of Scaleout Systems. In this talk, my plan is to talk about how to collaborate on machine learning models, even amongst competitors in an environment where data security and regulations are getting more and more important. And this is a really interesting and quite deep topic. We only have 20 minutes, so I will try to keep quite a high tempo throughout this presentation. And you're all welcome to reach out, email me if you want a copy of the slides, which will have more information, and also to talk more about this topic. To kick things off, very quick facts. So Scaleout is a Swedish company founded in 2017 with offices in Uppsala, Stockholm, that are very focused on product development and working both with our own internal research and externally funded research projects and product development with a heavy focus on federated learning. And we have especially one product that we're developing, FedN, which is a run anywhere solution for federated learning that is aimed to handle lifecycle management of federated learning models and the governance aspect of federated learning alliances, so which is part of what we'll be talking about today. To kick off, you all know that data is the world's most valuable asset by now, and that today's AI frontrunners are big tech companies usually that are able to leverage their data assets best. The problem for most others is that most of the valuable data that we have is isolated in different forms. So it can either be data that we don't want to share for different reasons, that it's private or proprietary in different ways, or that we know that there's a future value and there's a risk if we give up this data now that we might be locked out from our markets forever. We also have regulated data that we're not allowed to share. So either with regulations like for health data or personal data, we also have classified information, and more and more we also have restrictions on data that we're allowed to export out of a country. The third case we call practical blockers, which is data that we cannot share. It can, for instance, be high frequency data generated by IoT devices, or when you are connected to an unreliable or very slow network, or simply have a very large data set that it's not practical to move around. And in this, when we talk about collaboration, we're mostly interested and will focus on the first two cases, data that we do not want to share and data that we're not allowed to share. But why should we collaborate, and especially collaborate using federated learning? And I think that the most important case here and most common so far is that we have enterprises that are thinking about how to enable and also be able to access the best possible model in a certain field. The other main situation that we have is when you have a group that have a common problem that really cannot be solved by anyone in isolation. You have to collaborate around this problem. And that can, in many cases, be competitors that will have to collaborate. There are many more examples of this. We'll put that in the notes in the presentation, so please reach out and we can talk more about other reasons to collaborate. I have one small housekeeping questions to deal with, and that is, okay, so we're collaborating using federated learning, and our goal is to enable the best possible model. But won't there be a performance hit when we talk about accuracy of using a federated approach versus having an approach where we pool and centralize all data? And this is usually the first question that you look at in a project, and in much of the literature and also internally we have done many experiments on this, that there is a very small accuracy penalty, or it's no accuracy penalty. But in many cases, the advantage of being able to collaborate and have access to a larger data set or larger database, that more than makes up for the performance hit that you have of using a federated approach. As I go forward with this presentation, I have a base scenario in mind. that we'll use as a model case. And then we'll continue to discuss around with this as a base case. So here we have a group of hospitals that collaborate around model training in medical imaging. The goal is for everyone to have access to the best possible model, while at the same time being compensated for individual contributions they make to improve the model. And this is a scenario that we are working on together with partners in different settings. One is you could, for instance, have a system manufacturer that have their system deployed at many different hospitals, or you have hospitals that want to collaborate with other hospitals when there is no common controller or owner of the data. But to start this off, we have to make a number of assumptions, and here I have 3 basic assumptions that we'll use as a starting point also in discussing different alternatives. The first one is that there is a trusted party that will handle the orchestration task of the federated learning process. The second one is that we have hospitals that trust each other to not sabotage the model by adding poisonous training or validation data, at least not knowingly, and that they will not try to recreate individual models or the global models in order to try to steal it. The third assumption is that hospitals want to be reimbursed for their contributions, but they will also contribute as much as possible without needing extra incentives to get started. Let's start with the first assumption, that there is a trusted third party to handle orchestration. One of the most sensitive parts of federated learning is the orchestration, and how orchestration is done does not only have a large performance impact, but it also a key role from a trust and security point of view. And that's because the orchestrator have potential access to much more information about the training process and contributions from each individual alliance member. And using that, they can potentially learn more about the data and also tamper with contributions. So there are a couple of soft ways to try to boost the trust in the orchestrator or in the orchestrator. 2 examples of that is, for instance, to have a runtime that everyone is able to audit and verify before getting started, and also that there are audit trails and public logs available to all alliance members about the federation and training process. But if there is no trusted party, and then there are also different ways to try to handle that, and here are a number of examples of specific that really address specific problems and that are all being worked on. First one is to use secure enclaves, which is available in most modern processors, in order to have code that runs in a secure environment that is tamper-proof. There are 2 related technologies around secure multi-party computation and homomorphic encryption that uses and operates on encrypted data to ensure that there is no data leakage. You can also use a fully open route using smart contracts and public blockchains to have a fully open process that makes the whole process completely tamper-proof, but you have many other challenges with that. And the last option, which is the one that we are mostly working on right now, is a combination of open source software, immutable audit trails, and I'll dig a little bit deeper into that now. So one possibility, if the orchestrator is not trusted, is a combination of these different methods, and that's we think that this is one of the ways that are possible right now using the state of technology that we have available and maybe the best possible route to develop. So we're working on this, and by combining open source software that gives you full auditability of the orchestration source code, so everyone can go in, make sure that the code, basically validate that the code should do what it's supposed to do. Then you can use a software fingerprinting method to make sure that the orchestrator is actually running the code that he or she is supposed to be running. And by combining this with an audit trail, and preferably an immutable audit trail, you can also verify that the orchestrator is doing what the code was supposed to be doing. So by combining these methods, you have a verification and validation method for the alliance and for the federation process as it's running. And the possibility to create an audit trail and also a mutable audit trail. So we're using blockchains to do that, and you can use many different blockchains, but we have been using the Ethereum public blockchain with quite good progress and quite good results so far. The second assumption is that the alliance members basically trust each other to be honest members and try to work for the best interest of the entire alliance. We have two different things that we can address here if we make an overview. And first one is data poisoning, and one method to address that. So that is basically that members would be training on a very bad, corrupted, or really different data set. You can make sure that there is a distributed validation set that the orchestrator handles that will check all potential contributions for a representative set basically across all alliance members. So another way is also to impose a fee on the individual alliance members. So that whenever they make or propose a contribution, there's a fee attached to proposing this. And that way you also make sure that the alliance members are certain, they must be more sure that their contributions is actually something that benefit the whole alliance. There's another side of this as well, and that is inference attacks, that alliance members will try to learn about either others' data and models, or they try to recreate the global model basically to make their own copy of it. A couple of different ways to limit risks in that. One is to limit the global number of inferences that can be done on a global model, so that there's a lifetime to that model, and then you have to restart training process with new data. You can also enforce individual limits on inferencing. Or you can have a method where you dynamically increase the cost of doing inferences. The third assumption is around reward contributions, and that all alliance members were willing to contribute as much as possible and were happy to just get rewarded for the contributions that they make. This is a really interesting topic, I think, and we can get much deeper into this. But starting off, I think that we can think about that there are both financial and also non-financial ways to incentivize contributing to a federated model, and especially doing that in different ways. So starting off, we can think about just different kinds of profit sharing schemes that, just how you reward participation. So that could be egalitarian, on an equal basis, everyone gets rewarded the same. You can also measure the marginal gains and improvements of a model, for instance, using a technique called Shapley or Shapley games. And you can also measure marginal loss, for instance, and change in marginal loss and get rewarded for that. But if we broaden this up a little bit, you can also think about a situation where, especially if you have many different data controllers that control lots of data, that you can make that data, or you can basically make yourself available for participating in alliance by setting a price for that, and say that I'm willing to participate here for this price, and by having a reverse auction where different data controllers bid against each other to participate, there's a possibility to create a market on the supply side of data. It's also possible to turn this around and think that the users of a model are setting up bounties, or basically fixed rewards, or different kinds of dynamic rewards based on whoever can provide a model update that meets certain criteria, and then reward for that, for those updates. You can also turn things around and have, if you have an interest of a long-running model, for instance, where you continuously need access and to new data, and you also want regular and trusted participants that have basically a high uptime, where you can base rewards based on reputation or assign reputation based on, like, for instance, these different factors. But then there are also, in many cases, where you can gamify the process in other ways. So, for instance, it is a lot of status in contributing to different open source projects, and you can imagine creating an open source model in a certain area and contributing to that. You get some kind of reward that's not financial in any way. And then you also have like cost-driven motivations, where everyone hopefully would be able to participate without gaining anything in return. I'd like to just finish up with diving a little bit deeper into one method called bonding curves that we can use to automate the relationship between price and supply. So what bonding curves basically are, that we can set a formula or a curve that dictates how rewards are distributed according to, for instance, model accuracy changes. And we can also use this to, for instance, early on in the life cycle of a model, like give outsized rewards for contributions, really to get a model going. And then as the model improves and there is more like general use for that model, rewards can go down. And we can also use this then to like funnel cash flow from, for instance, if we have a commercial model and that there's a fee, for instance, for inferencing this model, we can funnel that cash flow to where it makes most sense in order to basically create a network effect of getting data into this model and improving the accuracy of the model. But what this also enables is to think about the federated model as basically a two-sided market. Because now we can control the behavior both on the demand side and as well as on the supply side. So on the demand side, like I just explained, we can encourage early participation and model improvements. But on the supply side, we can also have different ways. So for instance, that it could be that inferencing is very cheap early on in a model life cycle where accuracy is not that good. But as we get better and better accuracy, and especially if we get to the best possible accuracy in a field, we might be able to raise this cost a lot and really to have a market price on inferencing on this model that is also like demand driven. What we can also do is that we can introduce fees for mitigating different kinds of unwanted behaviors. So if you have a model that grows with many participants, the overhead of the federating process is very large. So like I mentioned before, what we can do, we can add fees for proposing updates to the model. And with having those fees, we will filter out a lot of really unnecessary model update proposals. But we can also have other fees that we can think about. And really here is a lot of potential to be creative, and I think that there will be a lot of work done here, and we are definitely be part of those that are thinking about how to improve this process. So what we've basically been talking now about is how to create positive network effects in federated learning alliances. And that can be either by improving trust in an alliance, or by adding different forms of financial incentives in order to really boost contributions and make the best possible model. So this is a very vast topic. We've just started to talk about some of the few aspects that are possible here today, and please reach out to me to discuss this further. I'm really interested in this area and to talk with everyone of you about this. So please reach out, and thank you for today.